Alright, good morning chemistry class. Let's just jump right into our notes for today. And so, here we are. We talked yesterday about alpha, beta, and gamma decay. And so, let's look at this here. So, alpha rays and alpha particles that come from alpha decay can be stopped by a piece of paper. And so, if you were knowing you were just going to deal with those, you're doing alright. Now, beta decay is a bit more serious. See, it can go through a piece of paper, but it gets blocked by a normal piece of wood. And so when it gets blocked by this piece of wood, then you'd be safe from that. Now it can actually go into your skin a little bit, but it'll usually block off from there. Now, the gamma decay and the gamma rays that come out of this are very dangerous. Sadly, they will not turn you green like the Hulk and give you super strength. Instead, they will cut straight through the paper, straight through the wood, and are only really stopped by strong concrete walls. Without those concrete walls, you're having yourself a rough time. And gamma decay and gamma rays can go straight through your body, causing a serious problem, possibly even perforating or putting small holes in your body in general, in your different organs. Not something you want. And then finally, this fourth one right here is a neutron. Now neutrons, when they're emitted, can actually go through paper, wood, concrete, and have to be blocked by special layers of lead-lined walls. So when you're dealing with radioactivity, radiation, and nuclear chemistry, you need to take your precautions. You do not want to end up sick and in trouble. So that is why we teach this, because some of you may want to become nuclear chemists, and some of you may want the huge amount of money that comes with it. Even nuclear medicine is a really cool field to join in if you think about it. Now from here, we're going to talk about the alpha particle decay. Now let's look at this example. It says radium-226 transmutates by alpha decay. Write the nuclear equation that represents this process. And so what you are to do here is you're actually going to write what happens when this radium goes through nuclear decay. In this case, alpha decay, and you'll see that there. So you can see something like this would go on. Let me just show you. We have, get my cursor out here. Now this is radium-226. Okay, it's got all these here. When it goes through alpha decay, it actually loses 4 up here. And so you'd minus 4 from the number that's on top here. And then you would be left with radon-222. And then you lose 2 at the bottom here. And so this right here, when you lose this number, you completely change your element. Meaning that instead of being radium, you actually completely change back into radon. And then what's gone from that reaction actually turns into our alpha particle. So that's what's going on here. The top number, you minus 4. The bottom number, you minus 2. And then you see, and you look on your periodic table, what is the number, well, what is the element that is 2 numbers behind the element that I chose? For radium, in this case, it'd be radon. And then finally we have this alpha particle from that point. Or you could even write this, and you could say that the radium goes through that alpha decay process, it turns into radon, and it gives off a helium molecule, because the alpha particle and the helium molecule are both very similar. And basically by the time that the alpha particle is given off, randomly flying electrons will form around it to change it from alpha particle into just helium in general. So that is how alpha particle decay works for the most part. So let's go on from there, and you can actually see why, because the 4 from here goes here, the 2 from here goes here. Now beta particle decay is a little bit different. And so we're going to look at this here. It says, write the nuclear equation for beta decay of boron 12. Now you can see boron 12 right here at the top. And it's got a 12 and it's got a 5 at the bottom. Well, what happens is it actually gives off a negative from its nucleus, meaning that it actually goes up in this number here. So you just have to add 1 to this number here, the atomic number, and you can find what element it turns into. Boron is number 5, and so you go up 1, you get carbon, which is number 6. And then up here, this number stays the same. And you're left with, right here, a beta particle and this V. So let's see here. You know, right here is like, okay, so this turns into that. We already have this written up there, but it's good for your notes wise to see that. And then finally, or you could say that boron then changes into carbon 12 plus this right here. It's not really even an electron. We call it a beta particle from this beta decay. So it's not a full beta decay, it's just a partial beta decay. And so when you're going through beta decay, all you have to do is just add 1 to this bottom number here to get your new element. Now, we're going to go on to the last one here, which is gamma radiation. Now, the gamma radiation, you know, it tells you to do the same thing. It says, write the nuclear equation representing gamma radiation given off by the unstable radionuclide cobalt 60. Now, you'll see this here is cobalt 60. And when it gives off gamma radiation, notice it doesn't change at all. This portion right here does not change. So it's still cobalt 60, but you get this gamma particle right here. So this Y looking thing here is actually a gamma radiation symbol. And so you guys have been following along. You should be pretty sure what you are going to be doing for your assignment. You're going to be doing a couple of these. I'm going to ask you, what does it look like when a certain element goes through alpha radiation or beta, decay, alpha decay or beta decay or gamma decay in this sense. Now from here we go on to our next slide, and actually that's where we're going to end for today. Nuclear fission and fusion are the topics we're going to be talking about on Friday, and so make sure to look for your assignment on Google Classroom, and I will see you guys tomorrow. Have a wonderful Thursday.